Okay, so today we're going to talk about how to prove triangles similar. Okay, so not congruent, but similar. So last time we talked about proving triangles congruent, we had 5 congruency statements. What were those 5 congruency statements? Side, angle, side. Side, side, side. Angle, side, angle. Angle, angle, side. And HL. I think we never said side, 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 did we? We did? Okay. So we had all 5 of those. Now, to prove something similar, they're going to be a little bit different. So the ones that we're going to talk about today that will be similar, or proving similar, is going to be AA, angle, angle, SSS, which is side, 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 and then side, angle, side. Those are the only 3 that work for similarity, okay? So the first one that I want to talk about is angle, angle, and so that's the first slide on your sheet. Now for angle, angle, all you need is that 2 angles are congruent. So here we see that A is congruent to what angle? D, okay? And B is congruent to E, okay? So let's think about that. If A and D are congruent and B and E are congruent, if I add A plus B and subtract from 180 to get C, would the answer not be the same thing for C and for F?
Yes, it will.
Yeah, because if we thought of this as B being, let's say B was 30, A was 50. What's 50 plus 30? 80 minus 180 is... So C would be 100. If these are congruent, it would be the same thing, right? So as long as we have 2 angles congruent, that tells us all the angles are congruent, and therefore they can be similar. Now, do y'all notice how A and D are red, B and E are blue, and C and F are green? So when I write my similarity statement, because you'll be doing this today, the first one they did was red, blue, green. You would want the second one to also match red, blue, green. Does that make sense? Okay, let's try an example of that then. So this one says, explain why the triangles are similar and write a similarity statement. Okay, and so since we just talked about AA, we're using AA. So tell me one angle that you see is congruent.
A and D.
A and D. So A and D are congruent. Is congruent to angle D. Okay? Now, I need at least one more angle that's congruent to prove that these are congruent. What do you think? Very good. Angle ACB and angle ECD. What type angles are those? They're vertical angles. Okay? So that means that angle ACB is congruent to angle ECD. So we have 2 angles, and so the way you would write your similarity statement is I would write triangle, and then let's label. In what order do we want to write the letters A, B, and C? B, A, C. So if we say triangle B, A, C is congruent to, so see how B doesn't have any angle measure in it? So we have none, 90, and vertical. Everybody see that? We went none, 90, and vertical. So we have to do that same thing here. Which one has no measure? E. Which one has 90? D, C. So that means, sorry, I wrote is congruent. It is similar to E, D, C, and then we'd put by angle, angle. Okay? So there is our similarity statement. Does that make sense? Okay. Let's try another one. Okay? So this one says, explain why the triangles are similar and write a similarity statement. So we're still looking at AA. So tell me 2 angles that are congruent here. angle B and angle E. So angle B is congruent to angle E. Now, A is 43 and F is 47. So how does that help me?
Oh, you could add it to 90 and subtract.
Very good. We know that all angles in a triangle add to 180. So in this first triangle, we would add these two. 90 plus 43 gives me 133. Then I would need to subtract that from what? 180. And what's left? 47. So C is actually 47. So do I have another set of matching angles? Yes. We have C and F. Okay? So I'm going to write angle C is congruent to angle F. So now I can prove they're similar because I have AA. So I would write triangle. And how do we want to write the order of this? ABC? ABC is similar to, so we went 43, 90, 47. So we'd have to do the same thing in the other triangle. See how A was 43, B was 90, C was 47? So which one would be 43 here? D, E, F. Very good. And we'd put by what? Angle, angle, similarity. Okay? So this time we're proving without the proofs. What do you think about that? Good? Okay, let's look at the next. The next would be side, side, side. Now, when we were talking about congruent triangles, all the sides were the same. This time, all of them are going to have similar ratio or scale factors. So they're not going to be equal, but they're going to have the same ratio or scale factor. Okay? Y'all ready to try an example of that? Okay. All right, so here we have PQ, R as my first triangle, and STU as my second triangle. So PQ corresponds with ST because they're in the same order. So PQ is here, ST is here. So I need to find the ratio of these sides. So I'm going to do 3 over 4.5. So that's PQ over ST. Now, if you put that in your calculator, what does it give you? Okay, 2/3. If we kept it in a fraction, which I like fractions, if you did a decimal, it would give you 0.6 repeating. Okay? Now, we want to do that with every side to make sure that it's similar. So that means QR goes with what side? TU. So QR and TU go together. So I'm going to compare those sides. So is that going to be the same? Yes, we can see that it's the same exact fraction, which is 2/3. And then last would be 2 and 3. So if I set that up, 2 over 3, are all of these the same? So we have the same ratio. So that means if we have the same ratio of all the sides, it's going to be side, 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 and we can go ahead and write our similarity statement. So we'd write triangle. How do you want to write this? Honestly, I would write it exactly the way they have it up here because it makes it easy for you. It's already in order. PQR is similar to STU by side, side, side similarity. No. Okay, everybody good with that? All right, let's talk about the next type. So the next type is side angle side. So this time I'm going to have two sides that have similar ratios, and I'm going to have one angle that's congruent. Does everybody see that this angle right here, B, is between the two sides, like it's connecting the two sides, as well as E is between the two sides here. The angle has to be between the two sides for it to be side angle side. Okay? Hence why B and E are highlighted here, because they're in the middle. Okay? Let's try an example of this. Okay, so do we have two angles that are congruent? What two angles? Okay, so D is congruent to angle H. They're both 70. Okay, now I have to compare sides. So the first side that I really see is DE. So DE, what side should it correspond with? HJ. So HJ is right here. So that would be 2 over 1, right? Which is just 2. Now I want to make sure the other side matches that. It has to be the same. So we're going to look at DF, which corresponds with KH. So that would be 5.8 over 2.9, and when you divide that, what do you get? Yes, you get 2. So do my sides match? Yes, and we have one equal angle, so that means that I can say that these are similar. So I would write triangle DEF is similar to triangle HJK by side angle side. Okay, y'all good with that one? Okay, let's try one that looks a little bit different. So this next one, we want to verify that these are similar. So where would y'all start here? The angle? Okay, so we have vertical angles. Very good. So this angle is congruent to this angle, so I would want to write that. Angle TXU is congruent to angle VXW. So that takes care of our angle. Now we've got to compare sides. So what side corresponds with TX? VX. Okay, so we're going to compare these two sides. So that would be 12 over 16. So we can reduce that, right, to 3/4. Okay, and then we're looking at XU and XW. So that would be 15 over 20. Does that reduce to 3/4? Okay, do those match? Yes, so we have a side and an angle. So how would we write that similarity statement? VXW by side angle side. Okay, any questions? Alrighty. Let's look at another one. So this is kind of tricky for some people. Okay, so we want to prove that these are similar. And now we can use anything that we want. Side, 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 angle, angle, or side, angle, side. It's not a specific one. So what do you notice first about the two? There are two angles congruent, right? So what two angles are congruent? We have S and we have T. So I'm going to write angle S is congruent to angle T. So that gives us an angle. Now, if we could find one other angle, we could say they were similar. Angle what? We can't conclude V and U are congruent because they're not labeled. Now, I'm going to give you a hint because you've never seen one like this. What letter shows up in both triangles? Isn't R the same angle in both of them because it's coming from the same place? Yes. If I ended up separating these into two triangles, redrawing, and these are not going to be very good, so just bear with me, S, V, U, and then I drew the bigger triangle, U, T, R. Isn't R in the same spot in both? And it's the same angle because they match up perfectly. So we actually have that angle R is congruent to angle R because it's the same angle. And so that means that these are similar. So if I wanted to write a statement, I'd put triangle RSV is similar to triangle RTU by AA. Okay. Then, what does it ask me to find? RT. Okay? So the way that you would do that is, what side corresponds with RT? RS, which is 10. Okay? Do they give me another side, two corresponding sides? Okay. This one and this one, right? Okay, so if I let this be x, because I don't know what it is, can I set this up as a ratio? And then just cross multiply and solve? So 10 is to x as what? 8 is to 12. Then we would cross multiply here. 8 times x is 8x. 12 times 10 is 120. We divide by 8, and x would equal 15. So that means RT would equal 15. So when you solve for a side, you just set up the proportions and solve for x. Does that make sense? Okay, we're going to try one more like that just to make sure you got that. Okay, so on this one, what would you start out with trying to explain why they're similar? B and C. So B and C are congruent. Okay, so that's an angle. Do we have another angle that may be congruent here? Angle A, very good. So angle A is congruent to itself, and that's actually called the reflexive property, y'all. So that gives us by AA, these are similar. Now, they also want us to find CD. So would it be easier if we separated the triangles and then did that, or do you think you can handle it together? Okay, try it together. So, CD is x. What does x correspond with? 5. Okay? Now, this is where it gets a little bit tricky. 9 refers to the length from A to B, right? So is that length in the small triangle or the big triangle, A to B? Okay, so this is my small length. Now, in the big triangle, I actually want A to C. Very good. So to find the whole thing, a lot of people get tricked and think, oh, that length is 3. But how could the whole big side of the triangle be 3 when the small triangle is 9. So this whole thing, we'd have to add those together. 9 plus 3 would give me 12. Okay? So let's set up that ratio. Who wants to tell me how you'd set it up? Okay. 5 over x equals what? 5 is in the small or the big triangle? Small. So it's small to big, so we have to go small to big. So it would be 9 over 12. In whatever order you go first, you have to make sure you do that same thing second. So from here, we cross multiply. 5 times 12 is 60. 9 times x is 9x. We divide by 9. And that either gives you 20 over 3 or 6.6 repeating. Okay, do we have questions about that? If it's easier, please separate those triangles. I like doing that because it makes it easier for me to see. All right? Now, I have one more example, and then I'm going to show you a few on your worksheet. So here, this one says, explain why the triangles are similar and write a similarity statement. Okay? So, does anybody have an idea of how to start this one? What do you think? Okay. So, like, this side's congruent to this side, or this side's congruent to this side? To BC. So if these are congruent, what type triangle is this? Isosceles. So what do we know about isosceles sides and their angles? Like, how does that help us?
Like they go across, and like they're that the sides right here.
Very good. So if the two sides are congruent, the angles opposite are also congruent. So what is angle C? 70. Okay? Now, when you're given a triangle like this, your best bet is to fill in all the information you can and then look. So if this is 70 and this is 70, what is left for B to be if it has to add to 180? 40. Okay? And so, do we have a similar angle? B and Q. Okay, but I don't actually know what the sides are, so I'm going to need to see if there's another angle. So what do y'all think we can do from here? Very good. So she said, since this one is also an isosceles triangle, which means the angles across from them are going to be the same or congruent, and we know that this top one's 40, these two are 70, we can kind of imply that both of these angles would also be 70, because 180 minus 40 is 140. We divide that by 2 to get two equal angles, and that gives us 70. So do we have two more angles that are congruent? So we can either say A and P, or we can say R and C. Either way, we know that they're congruent how? By angle, angle. Okay? Now I have to write my similarity statement. So how would you want to write this first triangle? In what order? A, B, C is congruent. So we went pink, yellow, none. So we have to go pink, yellow, none here. So in what order would this one be? P, Q, R. Very good. Okay, so let's take a look at your worksheet real quick and make sure that we can apply this to the worksheet. Okay, so looking at number 1, I'm given 2 sides of a triangle in both. So if I have to use, and remember the theorems are either side, side, side. Could I use side, side, side here? No, because I'm not given all 3 sides. Okay. Then I have angle, angle. Am I given 2 equal angles? No. And then I have side, angle, side. So which one of these are we going to have to use? Side, angle, side. Now, I don't actually have an angle here, so what would y'all do? Very good. We have vertical angles. So this angle and this angle is congruent. Now, how do I figure out if the sides are proportional? We do what? Ratios. Okay? So UT, what side corresponds with UT? DU. Very good. So we could do 40 over 16, and that would be 10 over 8, which would be 5 over 4. Is that right? All right, and then we would look at 39 and 16, right? So 40 went on top, so that means 39 also has to go over on top over 16. Does that work? Yes, 5 over 2. Thank you. Okay, now is 39 over 16 going to give us the same thing? No. So are these similar? Nope. Not similar. So that one wouldn't actually work. So not all of them are going to be similar. We've got to figure out whether they are or not. Okay? Now, looking at number 2, which one of those do you think we would use? Very good. Side, 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 because we're given all the sides. So somebody tell me, what side corresponds with 84? 14. So let's compare that one first. So 84 over 14. Somebody reduce that for me. 6. Okay. What side corresponds with 48? So it's 48 over 8, 6. Perfect. Okay, and what about 72 over 12? 72 over 12, y'all said is 6 as well. So that is similar by side, side, side. Now, if we went C, B, A, then how would we go the other way? So we'd have to go the blue side. So F to G, we went blue side, green side. So we'd have to go blue side, green side, F, G, H. Okay? Let's try a couple more, and then I'll let y'all try them. Okay, so in number 5, if we were to prove this one, what do you think we would use? It does look like it's going to have to do with angles since we don't have any side measures. Now, do you see any equal angles up there? Okay, the only thing that we have is that this angle is congruent to this angle. So we have one vertical angle, or one set of angles that are congruent, but is this one with 3? Is there a 3 one in here? Is there one in with 2 in here? So this one would not be similar. Okay, and number 6. This is our last one. So number 6 looks very similar, right? Because we've done problems like this. So do you think we'd be using angle, angle, side, 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 or side, angle, side here? Okay, so we're going to try side, angle, side. Now, what angle is congruent here? Very good. K is congruent to itself. Okay. Then we're going to have to compare sides. So do we need to split this into two triangles? Okay. We'll split it into two triangles. So we're going to have K, B, C. K to B is 16. K to C is 25. Then we're going to draw our big triangle. What is K to L? 88. Okay, what about K to M? Yes, you would add 25 plus 107, which would be 132. Okay, perfect. Now, what side corresponds with 16? 88. So let's do that. 16 over 88. What does that give us? 5.5. Or you could leave it as a ratio. Okay, and then we have 25 over 132. What? Okay. So what is 16 over 88? 2/11. All right, and what about 25 over 132? Okay, so what did we get, though? Point 189. Okay, and what was this when you divided? 0.22 repeating. Okay, so do those match? No. So we couldn't prove it by side angle side. It would be not similar. So are y'all understanding what you're doing? Perfect.